Okay, this is section 2.7. Um, I'm going to start with example one, and this is all about solving equations in one variable, or basically solving rational equations, meaning I've got variables in my denominator. The first one is example one. That's about as basic of one as you get. This should be something you have done before, a little bit. I think we did it just a little bit in Algebra 2. And well, I wasn't your integrated one teacher, but we do a little bit of this in integrated one. So I need to clear my fraction, which means I multiply everything by my denominator, which means I multiply everything by my denominator here is x. So I'm going to distribute it to all parts. And yes, I can distribute across an equal sign. I prefer to just write one big set of parentheses. Saves me a little writing. X times x is x squared. X times 3 over x is 3. The x's cancel. X times 3 over x. My x's cancel. This is the beauty of multiplying through by my denominator. This equals 4x. I'll subtract 4x. And I get x squared minus 4x plus 3 equals 0. That's a quadratic. You may either use the quadratic formula or you may use my favorite method when I can use it, which is factoring. Multiplies to -3, adds to -4 is -1 and -3. So x equals 3 or x equals 1. I should always check my answers to make sure I don't get a 0 denominator. And neither of those give me a 0 denominator, so we are good. Okay. We're going to move to example 3. And we're going to solve this one. Hey, this is the same thing as example 1, where we factored x squared minus 4x plus 3 into x minus 1, x minus 3. So I'm going to multiply through by my common denominator. Since x squared minus 4x plus 3 is x minus 1, x minus 3, I'll just notate that right underneath here. My common denominator is x minus 1 times x minus 3. And I'm going to be a little over thorough in writing this out. I'll distribute all of this to all three for this first one, and I'll cut down my writing in the future. So that's 2x times x minus 1 times x minus 3. Remember that this is all over 1, so it multiplies to the numerator, times x minus 1. 1 times x minus 1, I don't need to write the 1, times x minus 3 over x minus 3. And equals 2 x minus 1, x minus 3 over x minus 3, x minus 1. And I'm going to start canceling things. The x minus 1s cancel here. The x minus 3s cancel here. The x minus 3s cancel here, and the x minus 1s cancel there, giving me 2x, x minus 3 plus x minus 1 equals 2. I'm going to distribute and subtract 2 from both sides. So I get 2x squared minus 6x plus x minus 1 and 2. 1 and -2 is -3. 2x squared minus 5x minus 3 equals 0 for both of those. And this does factor 2x x minus 3 plus 1. So 1 and 3 multiply to be -3. 2x times 3 is -6x plus 1x is -5x. That works. No, it doesn't equal x. My brain ain't fully working right now. It equals 0. So that means 2x plus 1 equals 0, and x minus 3 equals 0. X equals 3, x equals negative 1/2. Okay. What do I need to do with these? I need to check my answers for extraneous solutions. So I plug in to my original. 2 times negative 1/2 over negative 1/2 minus 1 plus 1 times negative 1/2 minus 3 should equal 2 times negative 1/2 squared minus 4 times negative 1/2 plus 3. And you can check that with the calculator, it will work. 2 times 3 over 3 minus 1 plus 1 over 3 minus 3. That's a problem. 3 minus 3 equals 0. You can't have 0 in the denominator. So 3 is an extraneous solution. I expect you to list your extraneous solutions to show me you know how to find them and that you know that they don't work. With rational equations, we get extraneous solutions when we divide by 0. Okay. We're going to do example 4, where we eliminate an extraneous solution. And here they've got everything on one side. X squared plus 2x. Again, that's x times x plus 2. They're usually not horrible to you. They don't give you something where you need to multiply through by more than a quadratic. So again, I'm multiplying through by my common denominator, x plus 2 and x. Well, when I multiply x plus 2 times x plus 3, the x cancels on the first one, leaving me with just x plus 2, x minus 3. When I multiply it to the second one, the x plus 2's cancel, leaving me with just 3x. And when I multiply it by the third one, it's just 6. Because the x and the x plus 2 multiply together to be x squared plus 2x when I multiply it to that, which means they cancel. So x squared plus 2x minus 3x minus 6 plus 3x equals 0. X squared plus 2x equals 0. Well, that's a problem. X equals 0 or negative 2 is what I get. This is a denominator here. This has no solutions. These are both extraneous. 0 gives me a 0 on that part. Negative 2 gives me 1 there. They both give me 1 here. As soon as I saw a factor that was a denominator, I know these are both extraneous. I just write ext usually for extraneous. This has no solutions. There's not a single solution to this equation. Nothing works. Number 5, they have you do some mixture problems. I do not like their method, so I'm going to show you an easier one. This says how much pure acid must be added to 50 milliliters of 35% acid. So pure acid is going to be 100%. When we do mixture problems, we take the percent times the amount. I don't know what the amount is, so I'm going to call it X. To 35%, 50 milliliters. So 0.35 times 50 equals, and I need 75% acid. 75, my total here, my amount part was X and 50. So I'm going to say that's X plus 50. This becomes a pretty straightforward equation to solve. I do need a calculator because I don't know what 0.35 times 50 is, and I don't have the brain right now to do this. 17.5. So yes, feel free, use a calculator. 0.75x plus 0.75 times 50 is 37.5. To solve, I'm going to move the 0.75x left and the 17.5 right. Yes, I'm doing it from both sides. I just don't want to write it on both sides because I'm feeling lazy. 0.25x, so x minus 0.75x is 0.25x. 37.5 minus 17.5 is 20. I'll multiply both sides by 4 now to make this a whole x, since 0.25 is 1/4. 80. I need to add 80 milliliters of 100% acid to get me 75. Okay. So finding a minimum perimeter, example 6, this is going to be applying it. Find the dimensions of a rectangle with minimum perimeter if its area is 200 meters. I'm gonna put this down underneath this. So area equals 200. This is a rectangle. That means 200 equals length times width. Perimeter is what I'm trying to find. That's 2 length plus 2 width. This is example 6. I'm using L and W instead of X. So I'm dividing both sides. I'm solving the one equation for W so I can substitute. Perimeter is 2L plus 2 times 200 over L. So P is 2L plus 400 over L. To find a minimum, I'm going to graph, and I'm going to use 2x plus 400 over x, because that's how I graph. And this will be y1. So I go to my calculator, my wonderful, lovely graphing calculator that's going to make my life oh so much easier. Clear out what I got. And I got 2x plus 400 divided by x. I'm not going to try to do anything to solve this. We'll see if it even shows up on my graph. I didn't think it would. Window. Let's just go out to 100. I don't think I need to go that far. But I'm looking at an area of 200. It's probably 20 by 20. No, it's less than 20 by 20. Let's go out to 40. My maximum, though, my perimeter is probably going to be, well, we'll go up to 200. It's probably less than my area, but we'll go up. Okay, now I see it. I don't care that much about what it is. So I'm going to use the minimum, just like I would on any other graph, to find the minimum. I go to a point higher than the bottom on each side. I don't care what my guess is. 14.14 is the length. Okay. So I know that L here equals 14.14. That's enough decimal places. That's 4 places. Width is then 200 over 14.14, which might also be 14.14. This might be a square. It is. My width is also 14.14. The minimum perimeter for maximum area is usually, actually, I think it's always a square, unless there's some sort of restrictions. We're going to do one more application like this of designing a juice can. Stewart Cannery will package tomato juice in 2-liter cylindrical cans. Find the height of the cans if the cans have a surface area of 1,000 square centimeters. 2 liters, so 2 liters is volume. These are cylinders. The problem is, and surface area is 1,000 square centimeters. You need to know this conversion for this. 1 milliliter equals 1 cubic centimeter. How about I write that correctly? So this is 2,000 milliliters or 2,000 centimeters cubed. 2 liters is 2,000 milliliters. Milli is 1,000th. So 2,000 equals, this is a cylinder, that's pi r squared h. Surface area of a cylinder is, formula. I've got top and bottom. So I've got two circles, those are pi r squared. And I've got the side, which can unroll into a rectangle. So here I've got, say, a cylinder. This is a cylinder with no top. If I unravel it, it's a rectangle with the bottom side being the circumference and this being the height. Yeah, I've unrolled a paper that goes around my cylinder, and the bottom is the circumference. Circumference is 2 pi r. I want to keep it in terms of r. I don't want to use d. H. And I am trying to, well, I just want to find when it equals 1,000 for surface area. So here I'm going to take my volume and I'm going to get rid of H. So I'll divide by pi r squared. And then I'm going to substitute that into the surface area equation. I can do a little simplifying here. I can cancel pi with pi and one of the r's. And I have to enter it with an x. 2 times 2,000 is also 4,000 over x. So that's what I'm going to put in the calculator. And then on the other side, it's y1. Y2, I'm going to make it 1,000. Two pi x squared plus 4,000 divided by x. And then we're going to do just 1,000 here. I'm just going to go to my window right away. That's probably plenty for x. If I'm looking at an intersection at 1,000, I need this y max to be at least 2,000. And I didn't need to go quite that far. There are two different radiuses. So we're going to find the intersect. The guess, since I've got two intersections, the guess is going to be whatever's closer. 9.65 and 4.61. Yes, I would use both of those to get different heights. The 9.65 has a height of 6.83. The 4.62 has a height of 29.83. Okay. That is section 2.7.